Hello everyone, welcome back to my channel. I'm Ridila. So in the today's topic we'll see what is Merkle Tree and Merkle Root. So what is Merkle Tree? So imagine a blockchain contains like thousands of transactions. Like if you want to verify every transaction one by one, then it would be a lot of time, it will take a lot of time. So and storage and computational power, everything. So to solve this problem, we have introduced a new data structure called as Merkle Tree. Okay. So Merkle Tree is a binary tree made up of hash values. It was invented by Ralph Merkle, and therefore it is called as Merkle Tree. Okay. So in a Merkle Tree, leaf node contains all the hashes of the individual transactions, and parent contains the hash values of the child, and the root, the topmost node is called as Merkle Root. So you can see even in this diagram. So Merkle Tree is a binary tree. What is binary tree? Binary tree is a tree which has only 2, 1 or 0 children. Okay, and it is formed by hash pointers, and it is named after its creator. Okay, so here you can see clearly like the T here is all the transactions, and these transactions are hashed, and these hash values are again combined into their parent child, and all this combinedly they are as like Merkle Root. Okay, the topmost. Okay, the root node is single Merkle Root, and it's the blocks. Okay, this Merkle Root is stored in the blocks, and the parent node, it is combined hashes of the children pair, and the leaf node is nothing but hashes of the individual transactions. Okay, so types of nodes in the Merkle tree. So first types of nodes in the Merkle tree is, first we'll go with the leaf node. Okay, so leaf node is nothing but that the bottom most root like node of the tree, and each transaction is hashed separately. Like for example, you can see transaction 1 is hash 1 into hash 1, and transaction 2 is hashed into transaction 2, like transaction 3 is hashed into transaction 3, transaction 4 is hashed into transaction 4. Okay, so these hashes are from the leaf, these hashes are stored in the leaf nodes. Okay, now what is non-leaf nodes? Non-leaf nodes are, there are intermediate nodes. Okay, like they're not the leaf nodes, they're not root nodes, this is the intermediate nodes. One minute, I'll just show you. See, these are the intermediate nodes. Okay, so yeah, so they store combined hashes of their children. Like for example, now here you see hash 1 and hash 2 are combined, and hash 2 they're combined and hashed to create h12. Okay, same way h3 and h4 are combined and hashed to create h34. Okay, this h12 and h34 are stored in the non-leaf nodes, and root node is the topmost node, and it is called as Merkle Root. It summarizes all the transactions present in the root block, and even if a single transaction changes, and the Merkle Root will be also changed. So that is how we will know whether it is we will check the integrity of the blockchain. Okay, you can see Merkle Root of hash of t1 plus t2 plus hash of t3 plus t4. Totally hash is nothing but h1 2 3 4 are stored in the Merkle Root. Okay, next is how is Merkle tree constructed. So you can see, let's understand with 4 transactions. Okay, t1 t2 t3 and t4. Okay, step 1 is nothing but hash each transaction. So we get hash h1 h2 h3 h4 of transactions t1 t2 t3 and t4. Now step 2, combine all the neighboring hashes. You can see here, so here h1 h2 h3 h4 has been generated. Now this in the step 2 we are combining h1 and h2, we are combining h3 and h4. Okay, and then step 3 we are combining all h1 and h12 and h34, and we will get the Merkle Root. Okay, and this final hash generated is called as Merkle Root. This process continues until only one hash function is remains. In Bitcoin, SHA-256 is used as in Bitcoin, Bitcoin uses SHA-256 cryptographic hash function to continuously hash transaction data. Okay, so here we are using hashing process, that is the hash function used in the hashing is SHA-256. okay. So next is the structure of Merkle tree. So first let's understand why do we need Merkle tree. So in blockchain, in each block there are thousands of transactions, to store and to compile, to to calculate or to verify those transactions we require a lot of energy power, and to even store them we need a lot of storage. So for that we have introduced Merkle tree. So in the Merkle tree, the transactions are first converted to hash values, and these transaction hashes are grouped into pairs. Okay, so the parent node hashes are again grouped into pairs, and together they form the higher level parent node, and that is called Merkle root. Okay, so the top hash is called Merkle root. Fine. So next we'll see how a Merkle tree is built. Okay, so first hash transactions, then h1, h2, h3, h4, and then pair and combine the neighboring hashes are concatenated, h1 plus h2, h3 plus h4, and then hash pairs. Each pair is hashed in h1, h2, h3, h4, h12, h34, and final hash of all these pairs is single root. This is Merkle root. Okay, so what is Merkle root? A Merkle root is a topmost hash in the Merkle tree. It acts like a fingerprint of all the transactions inside a block. Like instead of storing every transaction in block header, blockchain stores only the Merkle root. Okay, the Merkle root represents all the transactions together. If every one transaction changes, if any of the transaction changes, then the Merkle root changes immediately. So that is how it will maintain the data integrity and the security. So here also you can see a Merkle root is a topmost hash in the Merkle tree, and it is the final hash generated from all the transaction hashes in the Merkle tree, serves as a cryptographic summary of every transaction in the block, where T1, T2 are the transactions, H1, H2, H4 are the transaction hashes, and H12, H14, H12, H34 are the intermediate nodes that they are generated by the combining of hash of h1 plus h2, and Merkle tree is generated by is equal to hash of h12 plus h34. Okay, so this process continues until the single root has been generated or remains. So represents all the transactions stored in the block header, detects tampering. Okay.